For centuries, humans have gazed at the stars, wondering if we're alone in the universe. Mars, our red neighbor, has always held a particular fascination. The search for extraterrestrial life often begins with the search for water, the elixir of life as we know it. And guess what? We found evidence of water on Mars. Exciting? Absolutely. But before you pack your bags for a Martian pool party, there's a crucial warning. Never drink water from Mars. This isn't science fiction, folks. This is about understanding the real dangers lurking within that alien water. While the discovery of water on Mars is a monumental leap in our quest to understand the universe, it's not an invitation to quench our thirst. The water on Mars is far different from the water we have here on Earth, and consuming it could lead to consequences far more terrifying than a simple stomachache. So why is Martian water so dangerous? What secrets lie hidden within its molecules? Over the next few minutes, we'll embark on a journey to explore the red planet's deadly elixir, and understand why, at least for now, it's best to stick with good old earthly H2O. The search for water on Mars has been a long and arduous one, with tantalizing clues scattered across the Martian surface. We've seen evidence of ancient riverbeds, polar ice caps, and even hints of liquid water flowing down Martian slopes. But what we've discovered about Martian water is that it's far from refreshing. One of the biggest challenges is the high concentration of perchlorates found in Martian water. Perchlorates are salts that are toxic to humans, disrupting our thyroid gland's ability to produce essential hormones. Imagine the havoc that drinking perchlorate-laced water could wreak on your body. Think of it like this. Imagine adding a heaping tablespoon of salt to a glass of water. Not very appetizing, right? Now amplify that by several magnitudes and you start to get a sense of the salinity of Martian water. But it's not just the salt content that's a problem. Perchlorates are far more sinister. While we have technologies to remove perchlorates on Earth, deploying them on Mars is a whole different ballgame. So, while the presence of water on Mars is exciting, the high perchlorate content complicates plans for its use. We need to find ways to deal with these perchlorates or find alternative water sources to establish a sustainable presence on Mars. Life on Earth is teeming with microscopic organisms. From the depths of the oceans to the air we breathe, microbes are everywhere. While most are harmless, some can pack a nasty punch. Imagine encountering microbes from a different planet. Martian water raises the possibility of alien microbes. These microbes would be very different from Earth-based ones. They evolved under Mars's thin atmosphere and extreme conditions. Our immune systems evolved to deal with Earth-based microbes. We don't know how our bodies would react to Martian microbes. Exposure could trigger unpredictable reactions or new diseases. It's a risk we cannot afford without thorough understanding. This is why the search for life on Mars is so cautious. Picture this. You're parched, trekking across the desolate Martian landscape, and you stumble upon a pool of glistening water. You're tempted to take a sip, but hold on. That seemingly pristine water might be hiding a dangerous secret: heavy metals. We're not talking about the head-banging music genre here, folks. We're talking about elements like iron, manganese, and aluminum, metals that can be toxic in high concentrations. And unfortunately, Martian water seems to have them in spades. These heavy metals can seep into the water from the Martian soil, which is rich in iron oxide, the compound that gives Mars its rusty hue. Combine that with the lack of a protective ozone layer like we have here on Earth, and you have a recipe for heavy metal contamination. Now you might be thinking, don't we consume small amounts of these metals in our everyday lives? That's true, but the key is in the dosage. Small amounts of certain heavy metals are actually essential for human health. However, consuming high concentrations can lead to a whole host of health problems. Iron overload, for example, can damage your liver, heart, and pancreas. Manganese poisoning can affect your nervous system, causing tremors, difficulty walking, and even psychiatric problems. And aluminum has been linked to Alzheimer's disease. So, that refreshing sip of Martian water could end up being a heavy metal cocktail, potentially leading to chronic health issues. We need to find ways to purify Martian water and remove these heavy metals before we can even think about using it for consumption. Chapter 4. Frozen in a Martian deep freeze. Mars, the red planet, is a world of extremes. It's a place where temperatures plummet to bone-chilling lows, and the atmosphere is so thin that it makes Mount Everest feel like a relaxing day at the beach. And these extreme conditions have a profound impact on the state of water on Mars. Unlike Earth, where water exists in abundance in liquid form, most of the water on Mars is locked away as ice. The average temperature on Mars hovers around a frigid -80 degrees Fahrenheit, far below the freezing point of water. This means that any liquid water on Mars is likely to be found deep underground, where geothermal heat can keep it from freezing solid. But even then, the low atmospheric pressure on Mars creates a whole new set of challenges. You see, water boils at a much lower temperature when the atmospheric pressure is low. On Mars, water boils at around 10 degrees Celsius, which is just above the melting point of ice. This means that liquid water on Mars is in a constant state of flux, either freezing into ice or evaporating into the thin atmosphere. So even if we could find a way to access this subsurface water, we would need to develop advanced technologies to collect it and prevent it from instantly boiling away into the Martian air. It's a bit like trying to grab a handful of smoke. It's just not an easy task. Chapter 5. The Uncharted Chemistry of Mars. We've sent rovers, landers, and even helicopters to Mars, but the truth is, we've barely scratched the surface of this enigmatic planet. Mars is a world teeming with unfamiliar elements, exotic minerals, and chemical compounds that we're only just beginning to understand. And when it comes to Martian water, the same principle applies. The water on Mars is likely to contain a cocktail of dissolved minerals, salts, and other chemicals that we've never encountered before. These unknown compounds could pose significant risks to human health, and we simply don't have enough information to assess the dangers. Imagine encountering a plant with vibrant, never-before-seen fruits. Would you take a bite without knowing if it's poisonous? The same caution applies to Martian water. We need to thoroughly analyze its composition, identify every single component, and understand its potential effects on the human body. This is where the field of astrobiology comes in. Scientists are working tirelessly to develop new techniques and instruments that can analyze Martian samples with unprecedented precision. They're looking for signs of life, of course, but they're also trying to unravel the complex chemistry of Mars and understand the potential risks and rewards that Martian water holds. Until we have a comprehensive understanding of the chemical makeup of Martian water, it's simply too risky to consider it a viable source of hydration. We need to proceed with caution, driven by scientific curiosity, but tempered by a healthy dose of respect for the unknown. Chapter 6. The Missing Ingredients for Life. Water is often called the universal solvent because it has the remarkable ability to dissolve a wide range of substances. This property is what makes water so essential for life on Earth. It carries dissolved nutrients to our cells, flushes away waste products, and participates in countless biochemical reactions. But here's the thing, not all water is created equal. The water we drink here on Earth is rich in dissolved minerals and electrolytes, essential nutrients that our bodies need to function properly. Martian water, on the other hand, might be lacking in these vital ingredients. Think of it like this. Imagine trying to bake a cake with just flour and water. You might end up with something that resembles a cake in shape, but it certainly wouldn't taste very good. Similarly, consuming water devoid of essential minerals and electrolytes could have serious consequences for our health. Electrolytes, such as sodium, potassium, and calcium, are crucial for maintaining fluid balance, nerve function, and muscle contractions. Without enough electrolytes, you could experience fatigue, muscle cramps, and even more severe complications. Furthermore, Martian water might not have the right balance of minerals that our bodies need. Too much of one mineral or not enough of another can disrupt delicate biochemical processes, leading to health problems down the line. So, while the discovery of water on Mars is incredibly exciting, we can't simply assume that it will quench our thirst or sustain life as we know it. We need to thoroughly analyze its composition and ensure that it contains the essential nutrients our bodies crave. Mars awaits. A thirst for knowledge, not Martian water. As we've journeyed through the potential perils of Martian water, one thing should be crystal clear. This is not the time to toss back a glass of Red Planet refreshment. While the discovery of water on Mars is a monumental scientific achievement, it's crucial to remember that this alien water is far from benign. We have to be patient. We have to let science lead the way. Advanced technologies are being developed that might one day allow us to purify Martian water, making it safe for human consumption. But until then, let's stick with the tried and true, the lifeblood of our own planet, Earth's water. So for now, let the mysteries of Martian water fuel our thirst for knowledge, not our literal thirst. Let the scientists continue their exploration, let the rovers roam, and let's marvel at the wonders of the cosmos, one extraordinary discovery at a time.